students, I hope all of you are doing good. Let's start today's chapter, the triangle and its properties. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. We have studied in our earlier class that a triangle is a closed figure bounded by 3 line segments. Okay, and it has 3 vertices, 3 sides and 3 angles, which we already know. That is why it is called triangle. That is tri plus angle, meaning 3 angles. In triangle PQR, the 3 vertices are PQR, 3 sides are PQ, QR and PR, and the 3 angles are angle P, or you can see angle QPR, then there is angle Q or angle PQR, or angle R, you can say angle PRQ. The side opposite to angle P, is which one? QR. And side opposite to angle R is this side, that is PQ, and side opposite to angle Q is this side, that is PR. Okay. Classification of triangles. Triangles can be classified on the basis of number 1 sides, number 2 angles. Number 1, based on angles, acute angled triangle, obtuse angled triangle and a right angled triangle. And number 2, based on sides, scalene triangle, isosceles and equilateral triangle. Okay. Medians of a triangle. Median of a triangle is the line segment joining one vertex of the triangle to the midpoint of the opposite sides. There are 3 medians in a triangle. In triangle ABC, have a look. D, E and F. See, D, E, F. These are the midpoints of sides BC, AB and AC of the triangle. So, the 3 medians are AD, okay, BF and CE. These are the 3 medians. And you can see all the 3 medians of the triangle meet in a point G. Okay, this meeting point of the 3 medians of a triangle is called centroid. Remember that. Okay, your G is the centroid of the triangle. Okay, remember, while defining median, altitude, perpendicular bisector, angle bisector, don't make equilateral triangle or isosceles triangle because they coincide in figure. Always use scalene triangle. Okay. Altitude of a triangle. Altitude of a triangle is the perpendicular from a vertex to the opposite side of the triangle. There are 3 altitudes in a triangle, as you can see in this figure. In the above figure, PQR, PL is perpendicular. See, PL is perpendicular to QR. Okay. Therefore, PL is altitude from P to QR. Okay. Similarly, QN. QN is altitude to PR, and RM is altitude to PQ. So, we can see that all the 3 altitudes meet at a point O. This meeting point of the altitudes of a triangle is called orthocenter. Here O is the orthocenter of the triangle. Okay, student, now we have learnt 2 new terms. One is a centroid. Okay, the point at which 3 medians meet in a triangle. And next term is orthocenter. Okay, what is orthocenter? The point where altitudes meet, 3 altitudes of a triangle meet. Okay, so here this point, that is O, is the orthocenter, right? No more. Important facts about the altitude. Number 1, altitude is the shortest distance from the vertex to its opposite side. Number 2, one altitude of an obtuse triangle lies outside the triangle, as shown in figure 6.41. This altitude is outside the triangle. Okay. AD's altitude with respect to side BC and clearly lies outside the triangle ABC on CB produce. Number 3, in a right triangle, 2 of its sides forming right angle are 2 altitudes, and the vertex where right angle is formed is the orthocenter. Here B, this is the orthocenter. Okay. Let's do exercise 6.1. Question number 1, at the adjoining figure, in triangle ABC, D is the midpoint of the side BC. Hence, AD is what? AD is what? Median. Okay. AM is what? Altitude. Okay. And is BD equals to DC? Since D is the midpoint of side BC, that means BD is equals to DC. Okay, so true. And is AM smaller than AD? AM is smaller than AD. True, right? Next, no more. Special point, centroid in acute angle triangle. In the interior of the triangle, in right angle triangle, in the interior of the triangle, and obtuse angle triangle in the interior of the triangle. Okay, and orthocenter in acute angle triangle, interior of the angle, right angle triangle at that vertex where right angle is formed, and in obtuse angle triangle in the exterior of the triangle. Okay, next, angle sum property of a triangle. Another way of proving the above property. In any triangle, the sum of the measures of the three interior angles is always equals to 180 degree. Draw a triangle ABC. Okay, you will draw a triangle ABC. BC. Okay, through A, draw a line LAM parallel to side BC of the triangle. Okay, so this line is parallel to BC. LAM, right? Now, LM is parallel to BC. BC. This is a sign of parallel. And AC is what? AC is a transversal. Therefore, angle MAC means MAC, this angle. Angle MAC is equals to angle ACB, this angle. Angle ACB. Why? Reason is alternate interior angle. Okay. Now again, angle ABC. Angle ABC, this one is equals to angle LAB. Means this angle. Okay, reason is same, alternate interior angles, right? Now this is equation 1, this is equation 2. Okay, now angle LAB plus angle BAC plus angle CAM is equals to 180 degree. Why? Since LAM is a straight line and sum of the angles along the line is always 180 degree. Okay. Now, what will we write? We'll write angle ABC plus angle BAC plus angle ACB is equals to 180. Why? From equation 1 and 2. Okay. So, angle 1 plus angle 2 plus angle 3 is equals to 180 degree. So, it is proved that the sum of the three angles of a triangle is 180 degree, right? Next, exterior angle of a triangle and their properties. Draw any triangular PQR and extend one of its sides. Here, this side has been extended. Say QR to M. Then the angle formed, namely angle PRM. This is called exterior angle of the triangle. Similarly, by extending other two sides of the triangle, we get other two exterior angles. See, you can extend this side also, you can extend this side also. So, what will we get? We will get an exterior angle. Okay. As shown in the above figures, by extending PQ along L, we get angle RQL as other exterior angle, and by extending RP along N, we get angle QPN as third exterior angle. Okay. Now, properties of exterior angles of a triangle. There are two important properties of exterior angles of a triangle. Number 1, an exterior angle of a triangle is equals to sum of its interior opposite angles. Okay. Let us try to prove this property. Given in triangle ABC, angle ACE, as you can see, ACE is the exterior angle formed by extending its side BC along C. Construction. Draw CD parallel to BA. Now, CD is parallel to BA. Now, angle BAC is equals to angle ACD. AC is transversal, okay, and reason what will you will alternate interior angles. Also, angle ABC is equals to angle DCE. Here BC is transversal, and the reason is, as you can see, ABC and DCE, these are corresponding angles, okay. Now, angle AC is what? ACE is what? Angle ACD plus angle DCE is equals to what? Angle BAC plus angle ABC. Okay, so angle ACE is equals to angle 1 plus angle 2. Okay, hence prove that the exterior angle of a triangle is equals to sum of its interior opposite angles. Okay, remember this. Number 2, sum of 3 exterior angles taken in order of a triangle is equals to 360 degree. Okay, simple rule, exterior angle 1 is equals to angle 4 plus angle 1 is equals to angle 4 plus 6. Angle 2 is equals to angle 4 plus 5, and angle 3, exterior angle 3 is equals to angle 5 plus 6. Okay, so according to property number 1, exterior angle is equal to sum of interior opposite angles on adding. So when we'll add angle 1 plus angle 2, angle 3, we'll get 2, then in bracket angle 4 plus angle 5 plus angle 6. So 2 into 180 is equals to 360 degree. That is angle sum property of a triangle. Where we got this 180 degree, angle 4, 5, angle 4 plus 5 plus 6 is equals to 180 degree because of angle sum property of a triangle, right? No more. Taken in order means either extend each side of the triangle in clockwise or anti-clockwise direction. In figure 6.10, all the sides are extended in anti-clockwise direction, but they can be extended on clockwise direction also, as shown in figure this 6.11. Okay, there are 2 more special points in triangle. In center, point of intersection of angle bisectors of interior angles of triangle. Next is a circumcenter, point of intersection of perpendicular bisector of all sides of triangle. Centroid, orthocenter, incenter, circumcenter are 4 special points. Altitudes are concurrent, medians are concurrent, angle bisectors are concurrent, and perpendicular bisectors are also concurrent. Concurrent means passing through the same point, right? Let's do exercise 6.3. Find the unknown angles in the following figures. Okay, you have to find this exterior angle, and you know sum of opposite interior angles is always equals to the interior angle. So 40 plus 50, oh, it's 60 actually. 60 plus 50 is 110 degree. That means x is equals to 110 degree, right, students? Now, types of a triangle. 2 special triangles, equilateral and isosceles triangles. Equilateral triangle. A triangle with all the 3 sides equal is called an equilateral triangle. In an equilateral triangle, all the 3 angles are also equal, each being 60 degree. Verification. Draw 2 equilateral triangles. One triangle ABC. ABC of sides 5 centimeter each, and other triangle PQR of sides 6.5 centimeter each. Okay. Measure each angle of these angles. You will see that in both the triangles, each angle is of measure 60 degree. Okay. Next is isosceles triangle. A triangle in which 2 of its sides are equal is called an isosceles triangle. Remember, the angles opposite to equal sides are also equal. This can be verified easily using paper folding method. Okay, cut an isosceles triangle PQR on a piece of paper in which PQ is equals to PR. Fold it in such a way that Q lies on R. Here the line PM is called line of symmetry. You can see that angle R fits on angle Q exactly, which shows that angle Q is equals to angle DR. Thus, it is verified that in an isosceles triangle, the angle opposite to equal sides are equal. Okay, no more. In figure 6.13, measure QM and AB. Angle PMQ and angle PMR as well as angle QPM and angle RPM. Number 1, QM is equals to MR because PM is median. Angle PMQ is equals to angle PMR is equals to 90 degree because PM is altitude, and angle QPM is equals to angle RPM because PM is angle bisector. So what is the conclusion? In isosceles triangle, altitude from vertex to base, where at both the ends of base equal angles are formed, is always bisecting the base and the vertex angle. Okay. Exercise 6.3, find angle X in the following figures. Okay, so this is X. These two sides are equal. Therefore, the opposite angles are also equal. So, 50 degree plus 50 degree plus x is equals to 180 degree. Why? By angle sum property of a triangle. By angle sum property of a triangle. You know, the sum of the three angles of a triangle is always 180. So, by angle sum property of a triangle. Now, 50 plus 50, 100 degree plus x is equals to 180 degree. So, x is equals to 180 minus 100 degree. So, x is equals to 80 degree. Okay, so here the value of x is 80 degree, right. Next, triangle in equality property. Let us take the triangle ABC. This is ABC. Denote AB is equals to C. AB is equals to C. Okay. AC is equals to B and BC is equals to A. Now measure sides AB, BC and AC and find the sum AB plus BC. See, what will be the sum? AB plus BC is C plus A and AC plus BC is what? B plus A, right? And AB plus AC is equals to C plus B. If we compare the sum of pairs of sides of triangle, then we see that AB plus BC is greater than AC, or C plus A is greater than B, and AB minus BC is less than AC, or C is equals to C minus A is less than B. Similarly, AC plus BC is greater than AB, or B plus A is greater than C, and AC minus BC is less than AB, or B minus A is less than B. And AB plus AC is greater than BC, or C plus B is greater than A, and AB minus AC is less than BC, or C minus B is less than A. So these observations help us to state the important property of triangle called triangular inequality property, which is stated as under. Number 1, the sum of lengths of any two sides of a triangle is always greater than the third side. Okay. And number 2, the difference between the length of any two sides of a triangle is always smaller than the length of the third side. Okay. So try these. Which of the following cannot be possible lengths of the sides of a triangle? See, 3, you have given these pair. 3 plus 4 is greater than 6. 7 is greater than 6. So this is true. Okay. Next, let's do example 1. In triangle PQR, PM is median of the triangle. Prove that PQ plus PR plus QR is greater than 2PM. Okay, so in triangle PQM, first we will write PQ plus QM. Okay, in triangle PQR, PQM, PQ, see this is PQ plus QM is PQ plus QM is greater than third side, which is PM, okay, by triangular inequality property. And then in triangle PRM, PR plus MR is greater than PM. So this is equation 1 and this is equation 2. Now we will add both the equation. On adding 1 and 2, we get PQ plus QM plus PR plus MR is greater than PM plus PM, 2PM. Okay. Okay, PQ plus QR. Okay, see, QM plus MR. QM plus MR is what? QR. Okay, and then PR is greater than 2PM. So as proved, right? Let's do exercise 6.4. Is it possible to have a triangle with the following sides? You can add any two sides, like 3, we have given 3, 4 and 6. Okay, you can add any two sides, and then the sum of these two sides should be greater than 6, the third side. Okay, see, when you will add 3 and 4, you will get what? 3 plus 4 is greater than 6, 7 is greater than 6. So this, it is possible, okay, to have a triangle with the following sides, right? Next, right angle triangle and Pythagoras theorem. A triangle in which one angle is right angle or a 90 degree is called right angle triangle. In right angle triangle, each side has some special names. The side opposite to right angle is called hypotenuse. This is the hypotenuse, okay. Actually, hypotenuse is the longest side of the right angled triangle. The other two sides are known as legs of the right angled triangle. See, this is the hypotenuse, this is this side, and these two are the legs of the right angled triangle. Thus, in the right angled triangle ABC, right angled at B, AC is the hypotenuse, and AB, BC are the legs of the right angled triangle, okay. Pythagoras, a Greek philosopher, 570 BC to 490 BC, found a very important and useful property of the sides of the right angle triangle. This property is known as Pythagoras theorem and is stated as follows. In a right angle triangle, the square of the hypotenuse is equal to the sum of the square of its other two sides. Thus, in right angle triangle ABC, see, this is right angled triangle, right angled at B. So here hypotenuse is AC, so AC square is equals to AB square plus BC square. This is a Pythagoras theorem. It is also true that if Pythagoras theorem holds, the triangle must be right angled, okay. Example 2. Determine whether the triangle whose length of sides are 6 cm, 8 cm and 10 cm is a right angle triangle. Since 10 cm is the longest side, so it is hypotenuse. Means 10 square is equals to 6 square plus 8 square. 6 square plus 8 square. 10 square means 10 into 10 is 100. 6 square, 6 into 6 is 36. 8 into 8 is 64. Okay, now let's add. 36 plus 64 is 100. So that means the triangle is a right angled, right? Let's do exercise 6.5. One of the angles of a right angle triangle is 52 degree. Find the other acute angle. Okay. So let's say this is a right angled triangle ABC. Right angled at B, and one of the angles, any one of the angles is 52 degree. We have to find this angle. Okay. So what will you write? Angle A plus angle B plus angle C is equals to 180 degree. By why? By angle sum property of a triangle. Angle sum property of a triangle. Okay. So angle A is what? We have to find out. X. Angle B is what? 90 degree. Okay. Angle C is what? 52 degree is equals to 180 degree. Now X at 0 plus 2 is 2, 9 plus 5 is 14 is equals to 180 degree. So X is equals to 180 degree minus 142. So what will you get? 10 minus 2 is 8, 7 minus 4 is 3. So the other acute angle is 38 degree, right students? Now you will do practice of the remaining questions.